Okay, so we are following along with the presentation in this section. So now we're going to be factoring a trinomial where we have a number in front of the x squared. So we're going to move on to that one. So this one is definitely easier to use the box method. So I'm only going to do the box method. I'm not going to do the other one. But what we're going to do first is we're going to subtract 17. When I subtract 17, I get 3x squared plus 5x minus 2 equals 0. Remember, we always still want to get that equal to 0 on that side. And here are my values. So now what I'm going to do is I'm going to create my box. Okay, now how do I know it's a 2 by 2 box? Well, if this is squared, it will work out to be a 2 by 2 box that we're working with. If this were cubed, I'd have 3 columns and 2 rows, or 3 rows and 2 columns. Okay, and we'll get more into that once you get a little bit more into using the box method. But remember that first thing I want to do is I want to grab that x squared term and I want to put it in the upper left hand corner. I don't know why I put a 2x there. Just realized that after I got it. So that should just be a 2. So if you were questioning that, good catch. So then I have a negative 2 here. And then remember, the 5x is going to be split between these two boxes. So it could be 3 plus 5. It could be 6 minus 1. It could be anything. So we'll figure that out in a minute. So now how do I do that? Well, just like in the other problem, I'm first going to multiply the first term constant and the last term. Notice I'm not dealing with the x squared, just the number in front. So 3 times negative 2. So 3, I want to make sure you see this, equals negative 6. So I'm going to go ahead and do that. And notice here, same method. This is negative, so that means I'm going to have 1 positive and 1 negative. Okay, so I'm going to have 1 positive and 1 negative. And then I can see this is positive, so my larger number is going to be positive. So I'm going to put the positive on the right and the negative on the left. So we're going to go through and figure this out now. So we know that 2 times 3 is 6. Of course, if I add those up, I get 1. Another one is 1 and 6. If I add those up, I get 5. So there it is. So that would be my value. So which number goes where? It doesn't matter. So I can put negative 1 and 6 or 6 and negative 1. Doesn't matter. I'm going to go ahead and do it the second way just because I can show you it can. So I have my negative 1. Remember to put in the x. Put in the x. Of course, I didn't write in the 1 just because I didn't feel like it. I could have put a 1 there. It's okay to do that. It's not going to hurt it. And then we're going to do this now. So we're going to see what is common to 3 and 6. So what is common is 3. So 3 can go into 3. 3 can go into 6. What is common to x squared and x is an x, because x can go into x squared and x can go into x. Now we're going to go across the row. We have just an x, because commonality between 3 and 1 is 1. And common between x squared and x is just x. So then we'll go across here. What's common to those? We have a 2, no x. This is positive, so this is positive. We're going to look at these two. Notice here we have a 1 and a 2. What's common to those is just a 1. And then because this one is negative, has nothing to do with this, because this one is negative, we have a negative here, so it factors out to 3x minus 1 times x plus 2. We're going to set that equal to 0. Now, notice the difference. When I didn't have a 1 here, when I had a different number than a 1 here were my factors. You might say, well, how come I couldn't have just said x minus 1, x plus 6? Because that's not the answer. So notice here, this is what it actually factored down to. It's not even close to what this looks like. Not even really close to what this looks like. This actually has nothing to do with it, even though some of the numbers look like it might be. But you can see that this is how it actually factors out. So now we can solve both of them. 3x minus 1 equals 0. X plus 2 equals 0. I can add 1 to both sides, so I get 3x equals 1. Divide both sides by 3. I get x equals 1/3. Okay, and then on this side, I subtract 2 from both sides. I get x equals negative 2. And and then there are my two answers. Okay, so that's how we do that. Okay, so now the next thing that we're going to do is we're going to do the difference of squares. So this is a little different. We still want to get, notice we really want to have that be positive, so it already is. So I'm going to have to move that over to this side. So I'm going to subtract 81 from both sides. So I get 0 equals x squared minus 81. Now notice we don't have a middle term. That's okay. If you wanted to use the box method, then you would rewrite this as x squared minus 0x minus 81. So you'd write it that way. When we're going through it, you want to write it that way. But we're just going to look at a faster way to do it, because since this is a difference means negative. So difference means negative. Okay. Subtract either one that you want to think about. So subtract 2. Okay, so we can say subtraction or negative, doesn't matter. So this is a difference of squares, because remember there's a 1 here, and a 1 is a perfect square. What is a perfect square? A perfect square is a number multiplied by itself equals that number. So 1 times 1 is 1, 9 times 9 is 81. Okay, so a number multiplied by itself is equal to whatever that number is. So we can factor this right away. Okay, so what is the what are the two numbers that multiply to 1? Well, that's 1 and 1. And because that's x squared, we're going to put an x there in the first one. And then what multiplies out to 81? Well, that's 9 and 9. And then, because it's a difference, I put a plus and a minus, or a minus and a plus. It doesn't matter which way I do it. That's just the way that I have it. So therefore, x plus 9 equals 0, which is the first one. X minus 9 equals 0. So x equals negative 9, because I subtract 9 from both sides. And this one, I add 9 to both sides, so I get x equals positive 9. And there are my two answers, a lot faster when we're doing a difference of squares. And we don't necessarily always have to use the box method to do everything. Okay, so here is another perfect square. I'm going to go ahead and do this one right away just by subtracting 256 from both sides, and show you that once you recognize, you may not recognize 256 as a perfect square, but it is 16 times 16. And so this would come out to be x plus 16 times x minus 16 equals 0. Again, doesn't matter where you put the plus or minus. So x equals negative 16 from this one, because we subtract 16 from both sides. And x equals positive 16 on this one, because we add 16 to both sides. And there we got it really fast. And we are done dealing with these difference of squares.